My name is Janine Freeman. I'm an engineer on the System Advisor Model team here at NREL. And today's webinar will be on modeling wind systems in SAM. There have been a couple of past webinars on this topic, but since then we've completely redone the user interface and we've added several new features. So we're going to go ahead and go through the whole modeling process from beginning to end from a wind technology specific point of view. I will be using the 2015.1.30 version of SAM. This version is a major update to previous versions that's rebuilt from the ground up. So you'll notice that if you have older versions of SAM on your computer, they will look very different from this one that I'll be using. The new version adds several major capabilities, including, as I mentioned, a significantly revamped UI, parallel processing capabilities, a new, more powerful scripting engine, and a few other features. This webinar is part of the 2015 SAM webinar series. And I'd like to remind everyone at this point that this webinar is being recorded, and we will subsequently post this recording online. If you have questions as I go through, I'm going to leave some time at the end for questions, but you can also type them into the chat window. And the chat window is being monitored, and some of those questions may be answered as we go along. So in today's webinar, I'm going to talk through all of the steps of modeling a wind system in SAM. We'll go through the wind resource, turbine, and farm layout specifications, and we'll also go through the wind system-specific cost inputs and models. I'll also briefly run through some of the advanced features and how they can be applied to wind analysis, and then we'll wrap up with a sneak peek at some of the future work we're doing for SAM Wind. So the easiest way to show most of these features is going to be to do a live demo. So that's what most of this presentation is going to be. So I'll go ahead and switch over to the SAM welcome window here. And I will start a new wind project. So you'll see when you click on wind that there are a bunch of different financial model options. This webinar is going to focus on the technology-specific side, but I am going to go ahead and pick the single owner model because that will get us the wind-specific cost pages that I also want to go through. So when you open up a wind project in SAM, your first input page over here on the left is this wind resource input page. By default, you start with this wind resource file option. And there are actually a surprising number of options for just inputting wind resource. On this page alone, there are 3 different options. The first choice is to use one of the files in this list of included library weather files. This is a list of 37 representative typical files for the type of climate and location that's listed in these names here. And one thing to note about these typical files is that they're not representative of a specific year. They're representative of what you might expect in a more average or more typical year at that type of location. The second option on this page is to download a file from the NREL Wind toolkit. This is available for the continental United States. So I'll go ahead and hit this download button here and show you this window that pops up. You can pick your location either by typing in an address or by specifying the latitude and longitude. Another important thing I'd like to point out with this one is that you select a specific year of data in this option. So unlike the library files, which are a more typical file, any of these files that you download is going to be for that specific year. So if it had unusually high or low wind speeds, that's going to be reflected in your energy estimate. When you click OK, the service downloads the file automatically as an SRW file, which is the file type used for wind resource files, and it applies it to the project with this checkbox down here, which brings me to the third option, which is to use any wind resource file that you happen to have on your computer. And that's easily done simply by specifying that you want to use a file on your computer and clicking this Browse button to direct the computer to the appropriate file. One other thing that I'd like to point out is that you can actually add files to this library here so that if you wish them to show up when you start a new wind resource project in your library list, you can do that by navigating. I have the folder already pulled up, but it's your, the wind resource folder. And it's on your C drive in the SAM folder under the version of SAM that you're looking at for the newer versions of SAM. And there's a wind resource folder here. So if I go ahead and I copy a file that I have on my desktop to that folder, you can see it showed up here, Denver downloaded files. And then I go back into SAM and I click this Refresh Library button. It will automatically bring in that file that I copied and pasted into the wind resource folder. And one thing to note is that what's displayed in this description option, this is a line that's in the file itself. So if you want something different to be displayed in your library, you can go into the file and edit that text so that it will show up as what you want in this window. From that point, I'm actually going to go ahead and uncheck this so that I'm using the one that's in my wind resource folder instead of the one that's in the folder on my computer. So those are three options in the wind resource file realm. But if you go up here to this drop-down box, you can also select the wind speed weibull distribution option. This is a much more simple wind resource input page. As you can see, it only has the two inputs, the average annual wind speed and the weibull K factor. But this is really more of a research tool than an actual project evaluation tool. What this will do is it will create a distribution of wind speeds that look like the one you've specified, and it will run those for the correct amount of distributions. And it doesn't really look at an hourly basis per se. So you won't get the variation that you would normally get between night and day or between different seasons. The other limitation of this model is that you can only use a single turbine when you're on the wind farm page, which we'll get to soon, with this weibull distribution option. But it is a useful tool if you would just want to look at what a farm might be able to produce on an annual basis in a region with this type of wind characteristics. So I'm going to go ahead and switch back to the resource page so that when we get to the wind farm page, I can show you all of the options. So the next input page, which you navigate to over here on the left, is the wind turbine option. And again, we have multiple options for how to define the turbine that you're using in your project. By default, this select a turbine from the library option is selected, and the library shows up here. You can see we have a list of a number of common turbines. And the other option on this page is to define the turbine design by characteristics. So if I go ahead and select that button, it will bring up a different set of inputs that's available on this page and get rid of the library option that was here before. And what this does is it uses the NREL cost and scaling model to create this power curve that you see here based on these various inputs that you supply. This is also perhaps more of a research tool, but not as much as the weibull distribution option. This can be a useful tool if you know the specifications specifications of your turbines that you don't have the power curve, and it's not included in SAM's wind turbine library. And it can be a good starting point if you're looking at modifications to a wind turbine that you do know the specifications of. It may not be particularly representative for really unusual technologies. If you have, a different number of blades or something, I'm not sure how well it will capture that. But it's a pretty good starting point for a lot of the modifications that many people are interested in. Another thing I want to note on this page is that, again, you can add your own turbine to this library list here. And again, I have this folder already pulled up. But if you go to the C drive, SAM, and then the version that you're looking at, and this only works in recent versions of SAM, and then the libraries folder, there's this windturbines.csv file that I'll go ahead and open. And each turbine in the library shows up as a different row in this file. So you give it a couple of metrics, the name of it, the size of the turbine, etc., and then power curve. And then if you save that file and reload it into SAM, your new addition to the library will show up. So I'm going to go ahead and select the Define Turbine Characteristics option for reasons that you'll see later. So moving on to the wind farm page, you'll see that there are lots of options on this page. I'm going to go through them all because this can be a sort of confusing page. So bear with me as I try to explain the many different options that are available and the ways that you can model and tweak your model in SAM. So the first and easiest option is to select this Use a Single Turbine option. As you might guess, it assigns one turbine to the farm. And as I mentioned before, this is the only option that you can use if you've specified a weibull wind distribution on the wind resource page. But since that's not very interesting to show people, I'll go ahead and move over to this Specify Desired Farm Size input. And this is if you maybe aren't as interested in the detailed layout of your farm, but you know that you want more than a single turbine, and you don't want to have to go through all of the inputs. But you want to say, maybe I have a 25 megawatt farm. So what this feature will do is it will get as close as possible to your desired farm size, given the discrete turbine size that you selected on the wind turbine page. So in this case, I typed in a 25 megawatt system, and I can only get to a 24 megawatt system because of the size wind turbine that I selected. And to get to that 24 megawatts, it will use 16 turbines. The other thing that that option does is it automatically lays out the turbines in space here. It tries to lay them out as close to a grid as possible, a square grid, but it is based on the number of factors that are available in this number of turbines it calculates. So if it calculates that you need 17 turbines, the poor automatic sizing algorithm is going to put all 17 turbines in a row. With 16, it works out much better because it can actually get you a square of 4 by 4. So this is by no means a perfect or optimized layout. It's just a representative starting point for that number of turbines. So while we have this number specified and it has laid them out automatically, you can see that it's showing you what the details of this layout are in these grayed out boxes, but that you can't edit them yet. So if you want to actually edit the layout of the farm, you would go up here to this last option, the Specify Number of Turbines and Farm Layout. You'll see that it automatically applies what it calculated up here to these inputs to start with, so that you can start with that set of inputs and then modify them from there. And this is where there start to be quite a few options, so I'm going to go through each one of these. The turbines per row and number of rows are probably two of the more obvious ones on this page. where they specify the number of turbines per row and the number of rows of turbines. So if I go ahead and change this turbines per row to 5, you'll see that it updates on my turbine layout map here. So this can be a useful way to keep track of whether or not the inputs that you're giving SAM map to the farm layout that you think you're trying to input. And notice when you change the number of turbines per row or the number of rows, it changes the number of turbines in the farm calculated up here. The next input is the farm shape. So you have the options of square, rectangle, parallelogram, or triangle trapezoid. This triangle trapezoid layout is perhaps a little unique. It takes the turbines per row and puts that number of turbines in the bottom row, and then it decreases the number of turbines in subsequent rows as you increase. So this is, I'm not sure when you might use it, but it's an option that we have. I'm going to go ahead and go back to the square, rectangle, parallelogram option because that makes a little bit more sense visually, changing some of these other ones. So the turbine spacing here changes the distance in between turbines in a row. It is in units of rotor diameters because that is sometimes an easy way to think about how far apart your turbines have to be. And then if you change the turbine on the wind turbine page, it will automatically adjust the spacing even if the rotor diameter of the turbine is different. The row spacing is a similar thing. That will change the distance between the rows of turbines. So the reason that we have these two as separate inputs is that depending on your prevailing wind direction, you may give the farm more space in one direction than in another direction if you know which way the wind is usually going to be coming from. This offset for rows lets you stagger the turbines in a row. So if I go ahead and change this to 4, you'll see that every other row is placed in the middle of sort of the two surrounding rows. And this is a way that people might lay out a farm in order to lessen some of the wake effects. This offset type also lets you decide if you want to shift the stagger back and forth or if you want to make it sort of a continuous staggering, which ends up looking more like this parallelogram that we mentioned. And then the last thing is this row orientation. And this can be used to change the direction of the farm instead of just pointing, you know, the 0 degrees or north-based grid coordinate. So in this detailed farm layout option, there is another option, and that is to import your wind turbine locations in a file. So I have gone ahead and set up a file already that I will go ahead and show you real quick. All your file has to be is 2 columns of x coordinates and the corresponding y coordinates. And the coordinates are all relative to each other in this file. So they can be latitude and longitude locations. They can all be 0-based like they are here, or they can be based on another coordinate system of your choice. So if I go ahead and import that file that I just showed you, you'll see that it imported 11 turbines from my file and laid them all out in a diagonal row, which is what I had specified in the file. That's perhaps a little bit of a silly layout for a wind farm, so I'm going to go ahead and go back to the layout I had before. But I just wanted to demonstrate that option as a potential option, especially if you have large farms that you've already optimized the locations for and you have those locations in a file. The last inputs on this page that I want to mention are these losses and wake effects inputs. So this wind farm losses lets you specify just a loss factor, basically. So if you think that even to your best specification of a farm, you usually get about 5% less performance than that, you can maybe enter your 5% here. Or if you know specific assumptions that you have for wind farm losses, this is a good place to enter them. You can also change the turbulence coefficient of the land that you're putting the wind farm on. So if you have better information about that, you can adjust it. And this wake model option, we have 3 wake models available in the wind model in SAM. A more simple wake model, the park model, and an eddy viscosity model. So you can also change that. And finally, I want to point out this availability and curtailment input option. This lets you specify losses in multiple different ways. There's an annual loss option, which is perhaps a little bit redundant with the wind farm losses option, but you could use both. But you can also specify hourly losses. So if you know that certain hours of the year you're going to be shut down or something like that, you can go ahead and enter those into this 8760 box here. And the last option is to enable hourly losses with custom periods. And this is potentially an easier way if you know that, say, every April you're going to be shutting down for 2 weeks for maintenance. You can go ahead and specify all of April that your losses are 100% or something like that. So this can be used in a bunch of different ways, potentially easier than the hourly losses, depending on your uses. So now that we've walked through the multitude of options on the wind farm page, I'm going to go ahead and go over to the system costs option. And you'll see that there's quite a few inputs on this page, especially once I expand this box down here. But basically the system costs all boil down to 2 types of inputs. This total installed cost input and these operations and maintenance inputs. In the total installed cost, there are 2 components. There's the turbine cost and the balance of system cost. This balance of system cost can be broken down into lots and lots of other subcategories, as can the turbine cost. But this can be a useful place if you have sort of larger buckets that you know, okay, each turbine is going to be this much, or I know my whole balance of system is going to cost this. This is the place where you can input those numbers. We have 3 input options for each of those 2 costs. You can specify them as a cost per kilowatt, you can specify them as a cost per turbine, or you can specify them as a fixed cost. And these 3 different cost specification options all get added together for this total cost here. So if you know that each turbine is, $10,000, plus you'll have another $5,000 in auxiliary turbine costs regardless of how many you have, you could go ahead and enter 10,000 here and 5,000 here and get the costs to add up in this total bucket. So in addition to having these inputs here, there's also a variety of NREL cost models and default values based on recent data that can be applied. And that's what these 2 buttons up here do. So you'll notice that in order to apply the turbine costs or the balance of system costs, you'll need to select whether it's a land-based installation or an offshore installation, because the costs do differ between the 2 types fairly significantly. And all of these models populate eventually this total installed cost. They may use a variety of inputs to get to that total installed cost, but that is the number that they're all changing. And because the variety of models that we have is a little confusing, I went ahead and made a flow chart of what turbine cost is going to get applied if you hit that Apply Turbine Costs button. So depending on whether or not your turbine is an offshore turbine, you might hit this default value for offshore turbines. If it's not offshore, then it depends on whether or not you're using a library turbine on that turbine page. If it's not a library turbine and you've specified the design, then we can use the NREL cost and scaling model to estimate the cost for that turbine based on your inputs. If it is a library turbine, then we have two different defaults depending on whether the turbine is smaller than 1 megawatt or greater than 1 megawatt. And you'll notice that these default values are all in units of dollars per kilowatt, so it will adjust based on the size of your farm and turbine. Similarly, we have a flow chart for which balance of system default or model is going to get applied when you hit that Apply Balance of System Cost Estimate button. Again, it depends on whether or not it's an offshore turbine. If it is, right now we have a default value that's applied for the balance of system cost. But coming soon, in an upcoming version of SAM, we will have an offshore balance of system cost model that can be used. If it's onshore, then it depends on whether your total farm size is less than 20 gigawatts or not. If it's not, the NREL land-based balance of system cost model will be applied, which I'll demonstrate in a minute. If it is, then there are a couple of default values that can get applied depending on the size of the turbines in the farm. But in each of these cases, you could use the land-based balance of system cost model. It may overestimate the costs for the balance of system for your farm because it was designed to be used with large-scale wind farms. But if you have really no idea of where to start and you don't like either of these defaults, you could see what the cost model said as another point of reference. So I'll go ahead and go back to the system cost page. I'll go ahead and estimate my turbine costs now. And you'll recall that because I had selected the Design Your Own Turbine option on the wind turbine page, it estimated the turbine cost using the NREL wind cost and scaling model. And it applied that as a cost per turbine in this input box here. So if I go ahead and I select Estimate Balance of System Costs now, you'll see that this is the land-based balance of system cost model, which was added to SAM this past fall. So this cost model has quite a few inputs. You can get as detailed with these as the information you have for your farm, including what your construction time is, information about your Met towers, what type of things might be required for your installation. And it will calculate a variety of detailed costs that are more broken down for your balance of system. And once you've gotten those all set up, it will also add them up to your total cost estimate for your balance of system. And if I go ahead and hit this Apply BOS Estimate button, it will apply that total cost up here. And as I mentioned, there's a similar model for this land-based balance of system cost model coming soon for offshore balance of system costs. So now that I've gone over all of the technology-specific pages in detail, let's go ahead and take a look at our results. And my disclaimer here is that I've just changed a bunch of things for demonstration purposes. This is in no way any type of real or representative wind farm, so these results may or may not make sense at all. But they are a useful way to show you some of the things that you can get when you put in a wind farm design that does make sense. So you'll see here on the summary page that a selection of output metrics are shown automatically. It includes some performance characteristics, some financial metrics based on the model that you've selected, and a handful of graphs of some of the output metrics of interest. But there are also a lot of other ways to dig through and look at the results that you're interested in SAM. This graphs page allows you to create your own graph with any type of output metric that you're interested in. And this data page lets you browse through all of the available outputs at all of the available timescales. And then you can export this data to Excel or copy it to your clipboard or do a variety of things with it to look at just the data itself. There's also a variety of other options. The cash flow tab allows you to look at a detailed cash flow, and you can export it to Excel with equations for some financial models. And these other tabs feature a whole variety of ways to examine your output data, looking at different time series options, profiles, statistics, heat maps, scatter plots. And in fact, because my screen resolution is small here, there are even a couple others over here. So there are a lot of different output options when you do run a simulation in SAM. And I would encourage you, if you are interested in looking at some of those other ways, to take a look at the Intro to SAM webinar that I gave a few months ago. It's available on the SAM website on the learning page, and it goes through some of these options in a little bit more detail. The last thing that I want to do is go through some of the more advanced features and how they might be applied to SAM wind analysis. There's also a deeper overview of these in the Intro to SAM webinar, but I believe those were run with a PV case. So let's go ahead and demonstrate a few with a wind case instead. One of the features that I find the most useful is this parametrics feature down here. This allows you to run a parametric analysis on most of the inputs on any of these pages. So for example, if you want to run a parametric analysis on how changing a turbine design could affect your capacity factor, for example, I'll go ahead and select this quick setup option, which the difference between quick setup and just selecting inputs yourself is that this quick setup will create every combination of the variables that you specify automatically. I'll go ahead and add a few variables. Let's say I'm looking at a wind turbine design modification that would change my cut-in and cut-out wind speeds. So instead of just the default cut-in wind speed of 4, let's say it could have a cut-in value of anywhere from 2 to 6 miles per hour. I'll go ahead and update that. And again, I'm not really running through how to do this. Those details are in the Intro to SAM webinar that can be found on the learning page of the SAM website if you're interested. And let's say the cutout wind speed could be 3 different options, 20, 25, or 30. So I'll go ahead and make this increment of 5. And then I'll hit OK. It will ask me if I want to overwrite the table. And it has created these 15 permutations of the combinations of the 2 variables that I just changed. So now that I have my parametric situations, I'll go ahead and say that I'm interested in the capacity factor, what effect it has on that, and select that as an output. I'll go ahead and hit Run Simulations. And this is where that parallel processing capability comes in pretty handy, because that was fairly quick for running 15 simulations. And you'll see that parametrics populates the output metric that you are interested in, as well as creating a graph of the different results. So you can see here that for a given cutout wind speed, it doesn't actually appear to change between the 3 options that much. The cut-in wind speed, on the other hand, appears to have a pretty significant impact on your capacity factor. So that's just an example of the type of parametric analysis that you could perform in a wind simulation in SAM. Another one of the advanced options that I won't demonstrate at the moment is the stochastic simulation. Here you can select various input variables. You can define correlations between them, and then select the outputs of interest. And it will run a stochastic simulation on those distributions of input variables to give you an idea of the sensitivities of your project to those input distributions. I'll also point out the P50, P90 page. This is a little bit different in SAM than how it is in a lot of the industry. A lot of industry for wind looks at uncertainty values in order to calculate the P50 and P90. In this SAM capability, we actually have you provide a folder of weather files, and it will run each of those weather files and then calculate P50, P90 statistics from there. So this is a P50, P90 based purely on the uncertainty in the weather. This is a little bit more difficult to apply to a wind project because it can be harder to find long-term records of historical wind data to use for this functionality. SAM does require at least 10 different weather files to be input in order to calculate the statistics. But I'm sure that some of our users do have access to long-term historical data that they could run in this type of environment. The last advanced feature that I'll get to is this macros feature. Again, I won't go into as much detail as I did in the Intro to SAM webinar, or also the scripting webinar that was given recently goes into a little bit more detail on some of these things. And that's also available on the SAM Learning page. But I do want to point out that this is here. It's a new functionality in the new redo of SAM. And it allows direct access from the user interface to the cases that you've set up, or direct access to the SAM simulation core itself. And it also allows you to share scripts easily with people who might not be programmers. So each of these different script options that show up in this list on the left here are just scripts that are located in a certain file on your computer. So if I go ahead and go to this siting considerations macro, which is probably the most interesting one for wind, I can demonstrate some of the functionality. So you'll see in the middle here, the instructions on how to use the macro show up. And on the right, there are the inputs that are specific to this macro. The Run Macro button is a little bit hidden, but it's right up here. And then you can also view the code for the macro. So if you want to modify it in some way on your machine, you can do that. You would modify the code, save it, and then on your machine it would work that way. And as I mentioned, you can share it with others who put it in a certain folder on their computer, and they'll be able to run the same macro. So this really can be a powerful capability, especially for working with other groups of people. This particular siting considerations macro is taking data from the NREL Wind Prospector website. And it allows you to look at some of the siting considerations for your potential project site. So I think the clearest way to explain it will just be to demonstrate it. There are different options for which location you want to look at the siting considerations for. You can use whatever location, latitude and longitude are specified in your weather file, or you can enter an address or enter a latitude and longitude. So this option usually works pretty well. I will point out that with the typical files that are found by default in the SAM library, because those are not for a specific location, they don't have latitude and longitude associated with them. So you would have to use one of these other two options if you were using one of those typical files. And it will give you a warning if you try to use a location from a weather file and the location doesn't exist. But because I downloaded that weather file when I was on the wind resource page that did have the latitude and longitude, I should be able to just use the location in that weather file. And let's say I'm interested in looking at the considerations for a 20-mile radius of that latitude and longitude. So I'll go ahead and run the macro. It takes just a minute to go out, hit the wind prospector, get back some of the siting considerations, and then put them into a nicely formatted table for you. But you can see that some of the information that it returns for you is various land ownership, as well as some of the endangered species that might be present in your site. So this isn't to say that you couldn't build on a site that returns some siting considerations, but it's things that might be useful to think about how that will affect your project when you go to build it. So that just about wraps up my live demo portion of SAM. And as promised, I'm going to go ahead and wrap up with a sneak peek into future work that we'll be doing for SAM Wind. This year, we have 3 more major projects. One is to create a wind wizard, we're calling it, internally for now, that will help you walk through the many inputs and get new users more comfortably started using the wind model in SAM. We're also performing an intermodal comparison between SAM and AWS TruePower's OpenWind to take a look at the input structures, the consistency of outputs, and also to take a look at what opportunities might exist in the industry to expand wind modeling. We'll also, as I mentioned, be implementing an offshore balance of system cost model this year. And our list of future ideas is extensive. This is just a selection of some of the things. There are several capabilities that exist currently for solar models that don't exist for wind, but could be extended to work for wind as well, including sub-hourly modeling and better output reports. And there are other things that are potential interests for SAM, including better distributed wind modeling or uncertainty modeling. And in general, we welcome feedback on what you like about the SAM wind model, what you think could be a great addition. So please do feel free to email feedback about that or say it in the questions. So with that, I'm going to go ahead and wrap up. Thank you all for your attention. We have about 15 minutes for questions. If you do have questions, you can type them into the chat window, or if you are connected to audio and you can figure out how to raise your hand using GoToTraining, then we can unmute you to ask your question over the line. And while I wait for questions to come in, I will just remind people that this webinar has been recorded and will be posted on the SAM Learning webpage. So please feel free to forward it to people who might have missed it today that you think would be interested in it. And if you do have questions that we don't get to today, they can always be posted on the SAM Help Forum, or you can email SAM Support.
Thanks, Janine. There is one question that came in while you're presenting about, the question is from Terry, how well is the library turbine cost maintained and reliable?
The library turbine cost. I perhaps get a little bit of clarification from that, Terry. The library turbines currently don't have cost data. That's only available with the design your own turbine option, and that is a modeled cost.
So I think maybe there might be 2 answers. One is how often we update the turbine library, and the other is how often the costs and the cost and scaling, or in the NRel cost models, are updated.
Okay. The NRel cost model is actually undergoing an update in the near future. The current one was based on 2012 cost data. And as far as how often we update the turbine library,
I think that's a good question. This is Nate Blair speaking. So we work with the wind analysts here at NRel and update the turbine library when we have access to additional turbines. The SAM team activity does not do its own research to gather that data, but we rely on the rest of the kind of wind analysis community at NRel to provide that data to us. So I think we would like to do it more frequently, but we typically refresh the turbine library as possible and the cost default values with each annual release.